Welcome to our second video on implicit differentiation, where we address how do we actually complete our homework problems. Here we go, example 2. The first thing I ask myself is am I going to approach this implicitly or explicitly? I'm noticing this is not in y equals form, and therefore I'm going to take an implicit approach. Next, I want to honor that you could just keep it as is. I can differentiate the right side and it's 0 because the derivative of any constant is 0. And I could go ahead and I could use quotient rule on this guy. That's not wrong and that's not bad, but this is my hint. Again, I can't uncover those because I'm on a PDF. I would cross multiply. I would avoid quotient rule with implicit if possible. So I can think of this as 1 over 1. So I will have y minus x equals xy minus y squared. So just using cross products. Okay, so now we're going to do step 1. Step 1 is where we differentiate every term. Now, excuse me, when I differentiate y, the derivative of y is 1. However, because I differentiated a y variable, I have to use chain rule and include a dy dx factor. If you want to use y prime, you're more than welcome to do so. When I differentiate minus x, it's just a minus 1. I do not include a dy dx factor because I'm differentiating with respect to x. Friends, we have a problem. When I look at xy, and this is the tip, this is what is underneath that box. Anytime you see an xy, an x squared y to the third, an x times a y, you are going to have to use product rule. Okay, so let's do some scratch work. My f is going to be x, so f prime is 1. G is y, but g prime is not just 1, it's 1 dy dx. So when I do f prime g, that's going to be y, and then product rule requires me to add g prime f, so that's going to be x dy dx. Then I'm going to differentiate the last term, which is a negative y squared, so that's going to be a negative 2y, and that will also get a dy dx term. Okay. All right, so step 2 tells us we need to get everything with the dy dx on one side and everything else on the other. So this is just a matter of personal preference. I'm going to go ahead and keep dy dx on this side. But then I'm going to take this dy dx and move it to the other side. And I'm going to take this dy dx and move it to the other side. Then I'm going to keep the y and move that to the other side. Step 3, we factor out a dy dx on the left. So I have a dy dx. And this is going to give me 1 minus x minus 2y. And then last but not least, step 4, we are going to solve for dy dx. So if dy dx is being multiplied by everything in this parentheses, I divide by the parentheses. So final answer is that dy dx is equal to y plus 1 all over 1 minus x minus 2y. So again, if you want to use y primes, that's great. But my dy dx notation, I now have a derivative in terms of x and y. All right, next, example 3. We have to differentiate, but then they want to know what the specific slope is. All right, friends, what do you think my tip is going to say? Yep, when I see the x squared y, or when I see the y squared x, both of those terms are going to require product rule in order for me to differentiate. All right, so let's do some scratch work. When I'm differentiating the first term, my f is x squared, so that means f prime is 2x. G would be y, so that means g prime is not just 1, it's 1 dy dx. So f prime g is 2xy, and then g prime f is going to be adding an x squared dy dx. So that was the derivative of the first term where I had to use product rule. Now let's find the derivative of the second term. So the second term is, my f is y squared. So f prime is going to be 2y, but again, I have to include that dy dx factor because we're differentiating implicitly. G is x, so that means g prime is 1. So my f prime g is going to be 2xy dy dx, and my g prime f is just going to be adding a y squared. Now, don't laugh, because I have done this on the board, and this is where kids make bonehead errors. What is the derivative of 2? It is 0. And I sometimes have kids that accidentally write down the 2, throws the whole problem off. That's your calculus step. Everything else after this is algebra. Step 2, keep everything with the dy dx on one side and everything else on the other. So I'm going to keep the x squared dy dx, and I'm going to keep the 2xy dy dx, but I'm going to move the 2xy and the y squared over. Step 3, I'm going to factor out a dy dx on the left. And step 3, I'm going to divide both sides by whatever's in that parentheses. Once you start practicing, you should kind of see the formula or the pattern and how the algebra works every time. This question, though, I'm not done. This question wanted, what is the specific slope at 2, -1? All right, so that means I have to plug in some values. So at 2, -1, this means I would take -2 times 2 times -1 minus -1 squared all over 2 squared plus 2 times -1. Well, what I immediately notice is this is 4 and this is a -4, so I have 0 in the denominator. Up top, what is that going to give me? A 4 minus a 1, so I have 3. So ultimately, for my final answer, the slope at 2, -1 is undefined. You have a vertical tangent line. All right. As a reminder, if I ever go too fast or you need to go back, you can always stop, rewind me, you can mute me. If you think you can do it on your own, you can fast forward me. All right, here we go. We need to find, and you're like, what the heck is this? d2y over dx2. Friends, this means you need to find a second derivative. I know it's weird how they write it. Later on, I'll show you how my professors, why they teach it that way. But this is just dy dx notation. It's awkward for second derivative. All right. There is something, and I promise to point it out in the second derivative part, that you're going to have to know. But the first derivative part is easy. We already did it in the first video, but let's do it again just to remind ourselves. First of all, I pick implicit differentiation because this is not in y equals form. The derivative of x squared is 2x. It does not require a dy dx factor because it's just in terms of x, but the y does. Don't forget the derivative of 4 is 0. So 2y dy dx is equal to a -2x. And NOP tip, I highly encourage you to simplify your first derivative before finding the second derivative, and I think you will see why shortly. So our first derivative is the opposite of x over y, which is what we found in the part 1. So I'm going to erase to give myself some more room. All right, so here's what we know. We know that dy dx, our first derivative, is the opposite of x over y. Again, I highly encourage you to cancel those 2's. It's just going to make it more complicated for your second derivative. All right, let's do some second derivative work. So when I was in school, this is how the professors would teach me. They would say the second derivative of y with respect to x the second time. Whether you're convinced of that or not, I don't know, but that's how my professors taught me. All right, here we go. I want to honor you absolutely could write this and do product rule. That's not wrong. That's not bad. But I personally am just going to stick with quotient rule because I don't mind a fraction. I really don't want to deal with negative exponents, but that's my personal opinion. All right, here we go. If I want to do quotient rule, I'm going to do some scrap work at the bottom again and then erase. So my f is negative x, f prime is negative 1, g is y, so g prime is dy dx. So f prime g would give me negative y. Then here is where we're going to have something that we're going to have to deal with. Reminder that I get a negative from quotient rule, but because my f is negative, that's going to turn it into a positive, x dy dx all over g squared, y squared. Here's your issue. This is why your problem is not done and why we have something kind of goofy. I don't want your derivative. Right now, your derivative is in terms of x and y and the first derivative. I don't want it in terms of the first derivative. I just want a second derivative that is implicit. That means it's only in terms of x and y. So if you're wondering how in the heck do we deal with it, friends, we use substitution. I know what the first derivative is. I need to substitute it in for dy dx. So when I do that, I get negative y plus x times the opposite of x over y all over y squared. If this was a test question, I would be let's say this was an 8-point problem, this would be 6 out of 8. This shows me that you kind of understand that process. Why isn't this full credit? Because you have a complex fraction. We have to get rid of that. So the rest of this is just algebra, friends. This is no more calculus. All right, so what do? I have negative y, and when I multiply across, I get negative x squared over y, and that's all over y squared. Well, I can multiply this by y over y, so that this gives me negative y squared minus x squared all over y squared. And when I divide by y, excuse me, I have a mistake already. Math therapy, undo, 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 undo. Gosh, I love cancel. Cancel. I love the undo button. Okay, math therapy, here we go. This should have, oh no. All right, this should have just been a y. All right, math therapy, I have negative y squared minus x squared over y. Now divided by y squared, which is the same as multiplying by 1 over y squared. So final answer is negative y squared minus x squared all over y to the third. Now, I am letting you know that this is full credit for Nap. But when you look at Bob, this is what Bob writes for his final answer. He says that the final answer is negative 4 over y to the third. And kids go, what the function? Where did that come from? Here's where it came from. It came from the original problem. Don't we know that x squared plus y squared is equal to 4? Well, that implies that negative x squared minus y squared is equal to negative 4. So what did we do? We substituted in negative 4 for that negative y squared minus x squared. So that's where you came up for Bob's answer. So again, to be clear, this would have been full credit for Nap. But if you look at the back of the book or you look at the answer key and you're wondering where did they get that from, they just substituted in a piece of the original problem. 2 more to do, guys. We can do it. We can do it. We've got this. Okay. Find the points at which the graph has horizontal and vertical tangent lines. Okay. This is really more of an algebra question than it is the calculus question. The calculus isn't bad. If it wants tangent lines, that implies slope. This is nonlinear, so we have to do calculus. Then I have to choose if I want to do an implicit or explicit approach. This is not ny equals, so I have to take an implicit approach. What do? The derivative of 4x squared doesn't have a y, so I get an 8x. The derivative of y squared is 2y, but I need to include a dy dx factor. The derivative of negative 8x is a minus 8. The derivative of 4y is 4 dy dx. And the derivative of 4 and 0 are both 0. I need to keep everything with the dy dx on one side. So I'm going to keep the 2y. Again, that's a y if that wasn't clear. And I'm going to keep the plus 4 dy dx. But I'm going to shift the negative 8x to the other side as well as the minus 8 to the other side. Next, I'm going to factor out a dy dx. And last but not least, dy dx is equal to negative 8x plus 8 over 2y plus 4. That's the calculus piece of this problem. So now I need to go back and I need to address the question about horizontal and vertical tangent lines. So I am going to erase this work and just rewrite my derivative. Let's see if I can get fancy here. Okay, there we go. There's my derivative. All right, so how do we answer the question? If I want a horizontal tangent line, this implies that I would have a slope of 0. If I want a vertical tangent line, that implies I would want a slope that was undefined. So in order to find my horizontal tangent lines, I'm going to set the derivative negative 8x plus 8 over 2y plus 4 equal to 0. But when I do that and cross multiply, it's just where the numerator is equal to 0. So when I solve, negative 8x is equal to negative 8, so x is equal to 1. When I want to find vertical tangent lines, I set negative 8x plus 8 over 2y plus 4 equal to undefined. So that's 1 over 0. So ultimately, when you cross multiply, 2y plus 4 is equal to 0. So this is where the denominator is equal to 0. So 2y is equal to negative 4 and y is equal to negative 2. But friends, we're not done yet. We're not done because the question asked for points. So that implies x, y coordinates. So this is just algebra. To find my horizontal tangent lines, I have to take my x equals 1 and I need to plug it into the problem. And this looks like it's going to be awful, but notice how I'm doing this all without a calculator. It's really not so bad. So when I put 1 in, I'm going to get 4 plus y squared minus 8 plus 4y plus 4 equals 0. And look what happens. What happens is that all the constants cancel. I'm left with y squared. Actually, let me cut out a step here. I can factor out a y. So I get y plus 4 equals 0. And using the product property, or zero product property, I have y equals 0 and y equals negative 4. So when I put that information together, this means that I have horizontal tangent lines at the points 1, 0, and at 1, negative 4. I will use the same process for the y's. When I plug in negative 2 for y, I'm going to get 4x squared plus 4 minus 8x minus 8 plus 4 equals 0. Again, we're going to notice that all of the constants cancel. I can factor out a 4x and get x minus 2. And by the zero product property, I get x equals 0 and x equals 2. So when I put that together, I have vertical tangent lines at x equals 0, y equals negative 2, and at 2, negative 2. And we made it. We made it to our last example. I wanted to do a trig example. On this problem, I would not take an explicit approach because it is not in y equals form. And here's just an op tip. I'm going to go ahead and divide by 2. And if you're wondering, why would you do that, Nop? I get a fraction. I know, but when I differentiate 1/2, I'm going to get 0. So that's just a way that I can maybe just like avoid dealing with that 2 in front. Okay. Did you catch it? What am I going to have to use? I'm going to have to use product rule in order to differentiate. Why? Because I'm taking the sine of x times the cosine of y. So some scrap work that I will erase. F is sine x, so that means f prime is the cosine of x. All right, and be careful with your variables. This is not the cosine of x, it's the cosine of y. And because of that, the derivative of cosine is the opposite of sine, but then I have to multiply by that dy dx via chain rule. So f prime g. There is no way to write this as some type of cosine squared term. Your inputs are different. So I just have to write it as cosine x, cosine y. Normally you would add in product rule, but because of that negative, we have a negative sine x, sine y, dy dx. And again, the purpose of dividing by 2 is the derivative of any constant is 0. All right, so let's proceed with our rules. Everything that contains a dy dx is going to be on one side. So I move the cosine x, cosine y to the other side. Then I'm going to divide. And in dividing, the negatives will cancel. And full credit for NOP is cosine x, cosine y, all over sine x, sine y. But what do you think Bob's going to do? Bob's going to look at it, partition it this way and this way. So obviously, if you wrote down cotangent x, cotangent y, that's equivalent. So again, full credit for NAP. Bob probably would have written them as cotangents. Congratulations, you did it. You survived your first e-learning lesson. Let's talk about our learning opportunity because it's not the same that is in the pre-printed notes. Here is what I would like you to do. What is recommended, in meaning you do not have to turn in, but I would do, is the worksheet. It's not long. Practice. This book work is not recommended. You don't have to do it. If you are bored because you are at home with nothing to do, those are some problems that you could do out of the book that I would recommend for implicit differentiation. But to be clear, this is all that is recommended. In a separate post, I assigned WPE number 4, and you need to take a picture of that work and then go ahead and turn it in on Google Classroom. And that is due on Wednesday, and I'm not fooling, April 1st. I hope you are healthy. I hope you and your families are coping and doing well. And make sure you come and join us in a Google Meet to check in or ask questions, 11:30 every day. Thanks, friends. I hope you enjoyed.